All right, guys. I hope you had a good Christmas break, good 2 weeks off, and getting back into this here. We're going to start off with factoring. Now, factoring is something we've done before. We've covered this already. We covered it in Chapter 3 with quadratics, factoring those. We also covered it in Chapter 4 with higher degree polynomial functions, with sum and difference of perfect cubes, and factoring by grouping. So we've covered this before. We've done these before. And I wanted to start off the semester with this here, mainly because our next chapter, the first chapter we're actually covering, is rational functions. And what a rational function is going to be a function that has polynomials in the denominator, variables in the bottom of the fraction. And we're going to need to factor these to be able to solve them, to find values, to find asymptotes and other parts of it. So it's going to be good to factor. Now, it has been a little bit since we factored. So I always start off the spring semester with factoring. One, because it is going to be helpful to go back over before we start rational functions. And two, because we're starting off a new semester, might as well start off with something that we've done before, something that we've seen before. So we're going to be looking at factoring here. We're not going to do every single one on the note sheet because I have a feeling once we do a few, it's going to come back to y'all. You're going to remember these. Now the first problem here, problem number 5, because again, I pulled these from a worksheet for the ones that I wanted to do, is probably going to take the most time out of every single one. Not because, again, the problem itself is long. We're going to go back over the steps again. And whenever we factor any of these here, our first main step is to find the greatest common factor. And if we look at this problem here, is there a greatest common factor, a number or variable that will go into all three terms, or that all three terms have in common? Because 4 is for 12 and 20, but b squared does not have one. So since b squared, the number in front of it's 1, we don't have a greatest common factor with a number, and since all three terms don't have the same variable, there isn't one for this one here. Our second step is our two sets of parentheses with 3 spaces. So for us here, I have a feeling doing these again the second time, you'll be a little bit better with it than the first. Now, our third step is to find the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. If the sign of the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. Now we can go on and list out the fourth and fifth steps. Fourth step is to find the factors of the first and third term. And the last step is to check. So these here are our 5 main steps with factoring. Now if we look back at this problem here, so we've got through steps 1 and 2. We found that there was no greatest common factor. We did our 2 sets of parentheses with 3 spaces. So our next step is the signs. And if we look at the sign of the third term, the sign is positive. If the sign is positive, the signs are the same and they match the sign of the middle term. So since it's positive, it matches the middle term, which is also positive. So we have plus and plus. Which moves us to step 4 to find the factors of the first and third term. Now the first term is b squared. Well, the only factors of b squared are b and b. If there's only one set of factors, we can go on and plug it in. Now we do need to look at the factors of 20 because 20 does have more than one set of factors. And we can always start off with 1 and 20. And we do have 2 and 10. 3 does not work, but 4 does. We have 4 and 5. And we can stop there because the next number that works after 4 is, well, 5. So those 2 sides meet up. So that's all the factors that we have. Which one of these 3 do we want to try first?
4 and 5.
So we could try 4 and 5 first, then we can do 2 and 10 next. And if we check this here, we will check the first kind of B, the outer 2 and the inner 2. We don't necessarily have to check B and B. We don't have to multiply it all the way out because we got B and B from B squared. They're the factors of it. So multiplying them back would just get us back to where we are. We don't need to really check that. 4 and 5 are factors of 20. We don't have to check that one there. We just need to check the middle term. B times 5 is 5B. 4 times B is plus 4B, which gives us positive 9B. Is that what we wanted? No. Now, flipping 4 and 5 would give us the exact same thing. So if we try 2 and 10, B times 10 is 10B. 2 times B is plus 2B, which gives us 12B. And that does match the middle term. So these here are our factors. Questions on this here? Any questions on these so far? Let's go on and look at the next one. So here, all right, guys, so we have a squared plus 4a minus 32. Is there a number or variable that will go into all 3 terms? No. So there is no greatest common factor. There's no common factor between all 3 terms. So we can move on to step number 2. Our 2 sets of parentheses with 3 spaces, which takes care of steps 1 and 2. Our third step is the signs. So we look at the third term. If it is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. So since it is negative, our signs are opposite. So we just have to pick one to be positive, one to be negative. It really doesn't matter at this point which one's positive, which one's negative, because again, our last step is to check it to make sure we do have the correct middle term. Step 4, factors of the first and third term. Factors of the first term, again, are nice because we're looking at the factors of a squared. Well, the only factors are a and a. There's only one set of factors for a squared that will work. Now the factors of 32. Well, we have 1 and 32. 2 and 16. Will 3 work? No, because a number is divisible by 3 if the sum of its digits are. So 3 plus 2 is 5. 5 is not divisible by 3. So 32 is not either. 4 and 8. And that's it. Because 5 doesn't work, because the number has to end in a 0 or a 5. And if we divided it by 5, we would get 6.4 as our answer. We know 6 doesn't work, so those two sides have met. So these are the only factors. Now we need to determine which one do we want to try first. 4 and 8. Which one do we want to be positive? 8. Because here the middle term is positive, so we want the bigger number to be positive. And we can check. And if we check this here, a times negative 4 is negative 4a. 8 times a is plus 8a. And negative 4a plus 8a is positive 4a. That is the middle term we wanted. So these here are our factors. Any questions on this so far? Any questions on anything we've done so far? So hopefully at this point, a lot of this is coming back. You're remembering it from last semester. And hopefully this time around, it'll be a little bit easier than it was the previous time. We'll look at one more of these here, then we'll move on to the next type. Now, for some of these here, and on the homework, there is one that will not factor at all. And up to this point, we did not cover a specific way to check it, because most of it was just running through every possibility, and if none of them worked, then it doesn't factor. This here is a way to check to see if a quadratic will factor. B squared minus 4ac. This here should look familiar. If you remember the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And the reason that this here is a way to check it is the numbers that come out of it. If we get a rational number or an integer, a number that is not have I or has a non-repeating, non-terminating decimal, then it actually factors. So for this here, b in our case is the negative 17. A is 1 and C is 72. So if we're having some difficulty with trying to factor it, we can check this here. So we can pull the calculator up and say second square root negative 17 squared minus 4 times 1 times 72. And when you type it in, it would be good to put the parentheses, especially around b squared, and we can hit enter. If the calculator gives us a integer, a number without a decimal, or a nice decimal, because if it worked out to be 12.5, that's a nice number. If it gave us 6.782942 and keeps going on, it doesn't factor. Here, it gave us a nice integer number, so it does factor. If the yellow calculator gives us a domain error, it doesn't factor, because for the 30xs, a domain error means that a negative number was inside the radical, If a negative is inside the radical, it means it's a complex solution. It does not factor. So this here does factor. And especially if you're having trouble with factoring it and you're not sure, this is a good way to check to make sure it does. Now the next thing we can look for is a greatest common factor. If x squared is the biggest one, no other term has x, that's not going to factor out. And if the number in front of x squared is 1, we're not going to have a greatest common factor. So here we don't. So we just have our two sets of parentheses with 3 spaces. Our signs, we look at the third term. Here the third term is positive. So the signs are the same and they match the sign of the middle term, which is negative. So we have negative and negative. Now we need to look at the factors of the first and third term. So the factors of x squared are x and x. Those are the only factors of x squared. Now 72 has a few more factors than that. 1 and 72. 2 and 36. 3 and 24. 5 doesn't work because it does not end a 0 or 5. 6 does. 6 and 12. 8 and 9. So one thing with 6 and 8, 6 works if 2 and 3 are factors. 8 works if 2 and 4 are factors. So we have all these here. Which one do we want to try first? 8 and 9. I wouldn't want to try 1 and 72 or 2 and 36 because they're a little too big. So 8 and 9. And again, lastly, we want to check. X times negative 9 is negative 9x. Negative 8 times x is negative 8x, which is negative 17x. Is that the middle term we wanted? So our factors are these here. Any questions over any of this so far? Do we feel comfortable with these here? Do we need to see another example like one of these here? So we'll move past 10 and 11. We'll look at number 8. Because number 8 is essentially the exact same thing. There's just one thing that changes. What is the thing that changes from this one here and the ones we've done already? There's a greatest common factor. So guys, what's the greatest common factor? What goes into all 3 terms? 2. So we factor it out. And when we factor a number out, we're essentially dividing every term in it by that number or term. So here, 2r squared divided by 2 is just r squared. Plus 6r divided by 2 is 3r. Minus 8 divided by 2 is 4. Now there is a problem on the homework where the only thing we can do is factor out a greatest common factor. It does not mean that it's not factorable. It just means, that all we can do is factor out the greatest common factor. And then this would be the answer. Now this one here does factor. So we'll need our 2 sets of parentheses with 3 spaces. Now the greatest common factor must be included as part of your answer. So that 2 has to be included. Now our second step is to look at the signs. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. So here, since the 4 is negative, we have positive and negative. We have opposite signs. Now we need to find the factors of the first and third terms, factors of r squared and 4. Well, the only factors of r squared are r and r. Now the factors of 4 are 1 and 4 or 2 and 2. Would 2 and 2 work for this here? Because what would that actually give us? 0. Difference of perfect squares, r plus 2 and r minus 2. Or they're the exact same but different signs in the middle is the difference of perfect squares. For those to work, it would have been r squared minus 4. So we're going to most likely, or we're going to use 1 and 4. Does it matter which one's positive and which one's negative? Which one, 1 or 4, is positive? And we can check it here. R times negative 1 is negative r. 4 times r is going to be plus 4r. Negative r plus 4r is positive 3r. Is that what we wanted? Yes. Because when we factored it out, the 2 out, we're not looking back at this. We're looking at this middle term here. So this entire statement is the answer. And as a reminder, if we get the correct number for the middle term, but wrong sign, we flip the signs. Any questions on this here? Does having a greatest common factor really change it? No, we just pull the greatest common factor out and move on from there. Any questions on any of this here? We feel kind of good with this here? Awesome. All right, guys, we have 2 left. So I want y'all to find the one in the note sheets that looks hand-drawn. We're going to start with it here. So looking at this here, is there a greatest common factor? 3. We can factor it out, which leaves us with 3x squared plus 10x plus 2. Looking at this one here, is there a way to multiply 3 and 2 together, or 1 and 1, because 3 and 1, 2 and 1 to get 10? No, that's a little small, isn't it? So if some of them look to be a little small or not possible, like when we did the earlier one with 72, we can try and look at b squared minus 4ac. If you've gone through and tried every possible combination of the factors of the first and third term and can't get the middle term, I would try this here. So our b term, because a is going to be 3, b is 10, c is 2. So here we'd have 10 squared minus 4 times a times c. And we're going to see what we get. So we can just stick this in a calculator exactly as it is. Squared minus 4 times 2. Well, we have either way a non-repeating, non-terminating decimal, yes? Is this a rational number? No. What that tells us is that this here does not factor further. There's no way we can write it as 2 sets of parentheses and get the factors. Now it's not factorable because we factored out a greatest common factor. So there is a factor we can do to it. There's something we can do to it. So this here is the final answer. So sometimes there's one of them on the homework that all you can do is factor something out. There's only one of them like that. Questions on this here? Oh yeah, okay, 3 and 2. I did 5 and 2. But we get to the same spot. Because the last one, I'll go back in here, it should have been 3. I was thinking of the next one, so 8.7179, we still get that there. Now this one here, so again, we're looking at 5 and 2. Because thinking through the process, our third step is the signs. Third term's positive, so the signs are the same and they match the sign of the middle term. So that means the number's going to go up. There's no way to bring it down. 5 and 2. So we can try this. So second square root, our b in this case is 9 squared plus, not plus, minus 4 times 5 times 2. We have a non-repeating, non-terminating decimal. So this will not factor. Did we have a greatest common factor? No, so this here is not factorable. Or in some cases, it's fully simplified already. And there is one on the homework that works out to be this here. So one of the ones on the homework assignment is not factorable, and one of them has just a greatest common factor.